right, for number 4, I feel like a lot of people find this one intimidating at first because, 1, there's a radical in it, and 2, it doesn't look like you can do much with it. There's not really a lot that we could do with it. However, if you look at each term, if you wanted to make this look a little bit less complicated, you could replace cosines with x and tan with y. So that would give us 4xy minus 2 square root of 3, and we said tangent was y, so I can put that as a y. And simply put, when you take a look at both of those terms, what they both have in common, they both have a y, and they can both be divided by 2. So we have 2 here, and since 4 can be divided by 2, that's something else that we could take out. So basically, all we have to do on this is take out a greatest common factor. So if I take it out in terms of the x's and y's, what it's going to look like is if I take out a 2y, what I'd be left with is a 2x from the first term. And if I take out 2y from the second term, the only thing that's left is a square root of 3. So if you want to do that, you can. If you just want to keep it written as is and factor it, same idea, except what you'd be taking out instead of a y would be a tangent theta. All right, what you'd be left with would be a 2 cosine theta, and then minus just the square root of 3. All right, so I think the tricky part in that one is just getting it factored to begin with. And once you get it factored, you can set each of your factors equal to 0 and solve. So the first one, if you take 2 tan theta equal to 0, go ahead and divide both sides by 2. So we end up looking for where tangent is equal to 0. So tangent is equal to 0 on the x-axis, so the angles of 0 and pi, and we'll come back to that in a little bit. I'm going to take this other guy and set it equal to 0. So I have to start by adding the square root of 3 to both sides. So we have 2 cosine theta is equal to positive square root of 3, and divide both sides by 2. So we're looking for this one, where cosine would equal the positive square root of 3 over 2. So cosine is going to equal radical 3 over 2 at the over 6 angles, and it's positive in the first quadrant, so pi over 6, as well as the fourth quadrant, so 11 pi over 6. So if your direction said solve it between 0 and 2 pi, those 4 angles there would be your final answer. The directions for these say solve it for a general formula. So for this first pair, that's pretty obvious. They're pi apart from one another. So we can say 0 plus pi k. You could also just say pi k. You don't technically need the 0 there. And then for both of these other angles, they are not pi away from one another. So we're going to have to keep both angles in our general solution and add 2 pi onto both of them. And that's just going to give us all of the other coterminal angles that would work to make this equation true.